violation, it says, no, you cannot go to this site. There's something fishy going on. So China, that didn't really work so well. Like I said, it's strict. It enforces that the correct cert is used. It also enforces that HTTPS only is used. The way that you use it, you set the strict transport security header. You can set the max age. This is for the cert. You can also say include subdomains. So if we have this set on github.com, it would also apply to gist.github.com, raw.github.com. So the migration path for implementing this, you add the header, and it works. It's pretty awesome. This is one of the easier security features. This is a huge win. If you're running a site that's public-facing, you should probably have HSTS. And you should obviously have all your stuff running over SSL in the first place. Some problems with this, there's still a small window where you can be attacked, which is before the browser has made the first request to the website. So before the browser has ever seen this HSTS header, someone could do a man-in-the-middle attack by capturing that initial request to http://github.com. The solution to this is browser cert pinning. So some of the awesome guys at Google working on the Chrome team, they included a fingerprint of the github.com certificate in Chrome. So when you download Chrome, it ships with the GitHub certificate fingerprint, so that even the first time you visit the site, it knows what the fingerprint is, and it will error out if it sees the wrong fingerprint. So there's, but that doesn't really work for everyone, but it's a pretty cool way to narrow the window of attack for a man-in-the-middle attack. Another thing that you might be asking yourself if you do web application security, if you're used to running burp or fiddler, which is an intercepting proxy that you are intentionally running that is going to run on HTTPS traffic, it does not break that. If you have a cert installed locally, so for PortSwigger, if you're using burp or fiddler or whatever you happen to be using, it will allow that. So that's not going to break your intercepting proxy. Same thing if you're at a company that has a corporate proxy that's intercepting all the traffic. If the cert is installed locally, it's not going to break your proxies.
Cool. All right, so the next technology we're going to talk about is cross-origin resource sharing. This technology actually has a pretty good adoption rate, so this is definitely something that you can use. And you know, the main issue with CORS, or what it actually solves, is you know, you want to make an AJAX request to another domain and you get denied, right? Because it's a violation of the same origin principle. So the solution is with cross-origin resource sharing is you make a request specifying the origin header to another domain. The server responds with the access control allow origin header, and we'll look at some of the specifics behind that. In this particular example, it's a wildcard, so it's going to allow any origin. And the access is granted for that request. So let's take a look at an example here. So a client sends the origin header of bobsbacon.net. The server sends back the access control. Yes, I am allowed to access bobsbacon.net. If the client and server origin don't match, what happens is nothing. You actually just don't get the resource, and it's pretty much denied at that point. And what about things like cookies, for example? It's pretty much the same, except that you're going to need to specify that you want to send credentials along with it. And obviously, this kind of falls in the fact of, if you're requesting resources as cookies, make sure you're doing other good security precautions and mechanisms. The server is going to need to send the following too, which is saying that you're basically allowed to send those credentials. So you'll see here that it's specifying that access control allowed credentials is set to true. So we'll take a look at some of the headers and some of the things you can do with simple requests. The simple requests are basically, what we saw in a few slides prior here, where we make a request and the server sends back the access and we're allowed. So for doing simple requests, we're allowed to do things like get, post, and head. And we're also allowed to request these kinds of simple headers, things like accept, content language, content type, only the types that are listed below here. So things like forms, form data, and text plain documents. Things can get a little bit more complicated, though, if we want to do something potentially using a different kind of HTTP verb. So maybe we don't want to do a get, post, or a head, but we need to do a put, or we need to do a delete method for some reason. Things can get a little bit more complicated, and we'll kind of walk through an example of what the difference between a simple request and a non-simple. So for the non-simple request, you need to do what's called a pre-flight request. And this is basically like a permissions check. It's saying, hey, am I allowed to do this stuff? The server sends back the permissions that are allowed, and then you actually facilitate the rest of the request. So it kind of looks like this. So here we have a request specifying the origin of api.bob.com. We're requesting the method put, and we're also requesting a custom header for the host api.alice.com. So we make that request. The server responds back and says, this is an allowed origin, api.bob.com. Here's a list of allowed methods. So we see get, post, and put. We requested put, so we see that that is an allowed method. And we also see that our custom header is also specified. So now we go ahead and facilitate that request, our put. We've specified the custom header's value. We specify the origin flag. And now we get a response back from the server. It tells us that the origin is allowed, and the request goes through. If you don't see a, if the server didn't send a response, you're going to get something like this, where you're going to see, it can't load this particular resource because the origin is not allowed by the access control allowed origin. So once again, those values have to match, and if they don't, the request won't go through. So, what's kind of the idea here if you're a developer and you're implementing this technology? These are just a couple of things you want to keep into consideration. Internet Explorer doesn't do CORS by default, so you have to send an X domain request object. Once again, if you're working on this, and just keep that in mind, there's a decent write-up on how to do CORS requests with IE. You also can't switch schema. So if you're switching between HTTP and HTTPS during the request, there's a possibility that you switch scheme, it's not going to work. The scheme has to match when you're making those CORS requests. And you need to be specific on the browser version. There's a decent list of cross-browser examples on the github.com/neohapsys page. So if you guys are interested, Ben actually used to work at Neo with me and has a decent write-up in a project called HTTP Shell that's kind of walks through some of this stuff. Another thing you got to just be careful with is a user credentials header. I mean, obviously, I kind of said that before, but anytime you're sending credentials across to other origins, that's something you need to be conscientious of. So this is something to keep in the back of your head. And really, CORS is useful unless you have cross-site request forgery. If your site's vulnerable to CSRF attacks, then CORS doesn't really provide you any additional security. So before you go about rolling out a strategy like cross-origin resource sharing, make sure that your CSRF stuff is tight and implemented correctly. So how many people are familiar with cross-domain XML files or see them when they're doing pen test or AppSec? And kind of, yeah, okay, a couple people. So don't do this, right? If you look at this policy here, you see that I'm basically allowing access from any domain, no security. I'm basically asterisking and wildcarding everything. Now what this actually means is, in this particular file here, we think about like the Flash cross-domain policy, and really what this is it's CORS for Flash. If we're allowing access from any domain, we're basically introducing CSRF into our application by hosting a Flash applet or some Flash, for example. So you need to be really specific on how you're allowing access for this stuff. And if you kind of do a Google Dork search for cross-domain files, you'll see that most of the sites just have them wide open like this, which is really bad practice. So definitely take a look at being a little bit more granular with your approach, and don't just wildcard everything, especially centered around Flash apps.
So another problem that we see a lot on the internet is cross-site scripting. For those people who do not know, cross-site scripting is when an attacker is able to inject JavaScript into the user's DOM. There's a lot of different ways that this can happen, but it's a big problem. The old fix, the traditional fix, is to filter input, which means don't allow malicious input, and to encode output, which is to do HTML entity encoding of the output that you're going to be reflecting back to the user. The problem with this solution is that it sucks and developers are bad at it. And it's not that developers are bad at it so much as it is that it's just hard. Whenever you see a cross-site scripting vulnerability, it's because the developer messed up or because a library messed up. or something was implemented wrong. This is not something that's easy, and that's why we still have cross-site scripting on the internet. It's still on the OWASP top 10. This is not a fixed issue. A new solution for it, and it's not so much a replacement for the old solution as it is something to augment it. You should still be doing the old solution. You should still be encoding output. But content security policy is a mitigation that it's a fallback. It's something you can rely on to address cross-site scripting when a developer does make a mistake, when you do have a bug in your application. And Neil talked quite a bit about it yesterday, so I'm going to be fairly brief. Here is what the browser support for it looks like. I showed this example at the beginning when I was showing the graphs. Support is not really there yet across all browsers, but it's getting pretty good, especially with Chrome and Chrome and Firefox. So it allows you to, you're essentially disallowing inline scripts and inline event handlers on scripts, or on HTML objects, disallowing dynamic JavaScript. Once again, Neil talked about all this stuff yesterday. The way that you set it is with the content security policy header, and there's a little bit of inconsistency here between browsers. With the Aurora version of Firefox, as Neil mentioned yesterday, they've moved to the standardized header. After the header name, you specify a directive, source expression, semicolon, another directive, and more source expressions. The directives that you can specify are default source, script source, style source, object source. The default source is what gets used if you don't specify any of the other ones. Script source says what domains you're allowed to, or the browser is allowed to load JavaScript from. Style source, what domains it's allowed to load CSS from. And, sorry. So yeah, here's an example CSP header value. We're saying that that scripts can come from somedomain.com over HTTPS on port 999. You can also specify these sources in any part of that, so you can just say the scheme HTTPS, you can just say the domain, you can do wildcards, you can do any combination of those things. You can also say self, so if this is on github.com, self would mean that we're allowing scripts from github.com and only github.com. You can also specify unsafe inline, which essentially defangs the whole header and says that we are allowing inline scripts, so don't do that. Unsafe eval, same deal, you're defanging this security feature. So in order to do this, it's not easy. You have to go through and remove all your inline scripts. If you have an existing web application, you probably have a lot of inline scripts. It's a big task to go through and remove all those. Once you get that done, you can add the header and you can rejoice. A few hiccups that you'll notice, as Neil mentioned yesterday, CSP breaks a lot of stuff. That includes bookmarklets and browser extensions. I thought it was funny that Neil called out LastPass, because at GitHub we see the same thing. They do not play well with CSP. Also, as Neil mentioned yesterday, the error reporting is not very good, though it's getting better. Some problems that you might run into, if you're going to whitelist sources, make sure that you control the sources that you're allowing. If you allow Akamai, then anything on Akamai can run on your domain. So if there is a cross-site scripting vulnerability, it's still exploitable. Make sure that you can control the domains that you're whitelisting. And also, as I mentioned before, if you're going to be specifying unsafe inline or unsafe eval, you're essentially defanging the whole thing and you're opening yourself back up to cross-site scripting.
Yeah, so actually the next technology we're going to be talking about has been actually proposed in the latest draft of CSP 1.1, which is another way to address cross-site scripting. So we'll touch on this approach, but be on the lookout for this to also be wrapped and tied into CSP. So cross-site scripting is still really sneaky. It's present on tons of sites. And one of the ways that we can protect against cross-site scripting is actually with browsers themselves. And so Firefox is cross-site scripting protection that's coming soon. The browsers all on the left here all have support for X-XSS-Protection. Here's kind of the overview of the technology. So we see that besides Firefox, pretty much, pretty good support. I think Firefox's main reason for not doing cross-site scripting protection is that they felt that this was just the wrong approach. And I think for some reasons there actually might be they might be onto something there, but we'll kind of touch on that a little bit later. So IE and Chrome are controlled by the X-XSS-Protection header. which operates in 3 modes. It operates in blocking mode, and then kind of this modification mode, which we can call mode 1, and then mode 0, which is basically like opting out. So let's take a look at how IE does it. So client requests a resource, server sends the header, and the browser either modifies or blocks the cross-site scripting. So in the first example here, if this is the header that's sent, this actually prevents the rendering of a page. So we can kind of imagine making a request to a resource. We pass in a parameter in the get string, and we put script alert 1. We make a request to that resource. The header is set. On the response of the server, the page basically is going to give you an about blank. It's not going to render any content at all. You end up with a blank page. Alternatively, if the cross-site scripting protection header is set to 1, this detects the cross-site scripting and then attempts to modify the page to block the attack. So it does some kind of dynamic heuristic stuff. It tries to render your page. It removes the JavaScript that was reflected back against the user and still tries to render the page for you. If it's set to a 0, you basically opt out of the protection altogether. So Chrome's implementation of this is known as cross-site scripting Auditor. Had a different name before, but that's what they've landed on recently. It listens to the cross-site scripting protection headers, but it's on by default. So if you aren't even sending these cross-site scripting protection headers, it's going to be turned on. However, if for some reason you really need to disable Chrome's cross-site scripting Auditor, you can go ahead and specify the X-XSS-Protection header to 0, and it'll listen to you. It's actually integrated directly into WebKit and has full support for WebKit browsers. As I kind of alluded to earlier, Firefox, it's coming soon. Do you remember the build that is doing that?
They were playing around with it on their nightly builds for a while, and I think it might have made it into Aurora a while back. OK, so it's definitely, that's coming up, so that'll be interesting to take a look at, especially for these kinds of things, which have been some of the problems that we've seen in the other browsers that have implemented this technology. We see here some false positives. So we have reflective cross-site scripting protection appears to target legitimate iframes as false positive, right? So this was a Chrome issue that somebody reported. So that's not good, right? You don't want to be busting your iframes on your application. That's bad. It's also not perfect. So here's an example of a XSS auditor bypass with the payload that you can see. Oh, you probably can't see back there, but basically right here. And if you kind of Google around and take a look at some of the bypass mechanisms, every few months or so, somebody comes up with a really crafty way to bypass the XSS protection, does a disclosure on it, and the browser companies fix it. But you can definitely see that it's not much different than blacklisting. So we can run into some issues if we're using this as our primary defense. It also doesn't protect against stored cross-site scripting, which I think is kind of obvious, right? Because how's it going to know that that wasn't part of the website in the first place? So if you're kind of using this as a protection mechanism against stored cross-site scripting, you're going to be out of luck. So what's kind of the path here for developers? You really want to just test if cross-site scripting protection breaks your application. Maybe some legacy code or something this is going to have an issue with, but in general, if it breaks it, fix your code. And if it doesn't break it, set it to block mode. And also keep in mind that this is really your last line of defense. At this point, you're really relying on somebody else to do the security for you. So you don't want to really rely solely on browser for cross-site scripting protection, but this is something that you can definitely work into your overall cross-site scripting mitigation strategy. And one of the things that'll be really nice, as I kind of mentioned earlier, is that they're going to tie this header into the CSP 1.1 specification. So you can actually kind of use that content security policy, not only to do all the stuff that Ben was discussing, but use this as an additional last line of defense on top of that CSP stuff to really give you an awesome layered approach for battling cross-site scripting. So when you're on an application pen test and you find a page where you provide input and it reflects it directly back to you, you get excited because you think you found cross-site scripting, and then you see that the content type is set to text plain, and then you are sad because your exploit isn't going to work. But sometimes browsers decide to render content type text plain as HTML. Internet Explorer has a long history of this, known as MIME type sniffing, where it actually looks at the content of the file to determine the MIME type rather than the content type header. Similarly, there have been similar issues with text plain in specific in other browsers. where a text plain document gets rendered as HTML. A solution for this is the no-sniff header. The browser support is pretty good. Firefox doesn't support it. Chrome does. IE does. Some of the mobile browsers are not supporting it very well, and they're actually doing even worse things. I was talking to the Apple guys. The mobile Safari, if it's text plain, it does not look at anything. It does not sniff the content type from the document. It only looks at the URL. So no matter what the URL is, it's going to render it as that type. So that's a big issue. And it doesn't even respect the no-sniff header. But Chrome and IE do, so it helps resolve that a lot. And essentially what it does is it tells the browser to stop sniffing the content type. So content type text plain actually means content type text plain. And this means that if you want a file to be used for CSS, you have to specify application CSS. JavaScript must be text JavaScript or application JavaScript, and so on. The way that you set it is with the X content type options header. You set the value to no sniff. And that's that.
Profit, yeah.
Profit.
That was another really easy one to kind of throw on. So we're going to talk a little about iframe sandboxing, which has pretty decent support with the exception of Internet Explorer. Internet Explorer 10 supports it, but most of the modern Firefox and Chrome browsers and Safari support this feature. So if you're on old IE, you're shit out of luck. And kind of the idea is here, the use case for this is the thinking of the example of hosting a third-party widget on your site, maybe for revenue or something like that. And should you trust these widgets? Would you let them access your DOM and execute scripts? Maybe you shouldn't. Should you let them read and write cookies, access local storage like a local SQL database? Would you let somebody hang out in your house if they paid you in high fives? Probably not, especially if you didn't know who they were. So really what Sandbox does is it provides restrictions for this stuff that we maybe don't fully trust. This does stuff like allow you to disable forms and scripts for those widgets. Allows you to disable plugins, disable those widgets from doing pop-ups, prevent links from targeting other browser contexts. So it gives us more granularity for what that content embedded in that iframe can actually do. So the way that it works is a browser parses this attribute, and then it enforces those restrictions. So here we have some company that has a widget, and we are specifying right here. We see we're just specifying the sandbox attribute, and that's pretty much it. From a security perspective, all these things here are ways that we can make the sandbox a little bit more open. So for some reason, if we need that content that's embedded in an iframe sandbox to be able to execute scripts and be able to work with forms and all this stuff, then we can actually turn all these settings on, kind of defanging some of the technology. So if you're a security auditor and you're looking at this stuff, see how permissive the sandbox is and if there's anything there that you could potentially use for your advantage. It's also not enabled by default. So in general, if you're creating iframes, you have to actually specify that sandbox attribute. It's not going to be there by default. So, and another thing kind of to mention is, this can potentially break frame busters. But one of the ways we can actually get away from frame busting technologies is using X-frame options. And so we'll kind of just go ahead and dive head first right into this one too. So X-frame options has really good support. Overall, it's green with the exception of some of the old versions of Internet Explorer. And really the purpose of this was to prevent clickjacking attacks. And I'm sure everybody here has some familiarity with clickjacking, so we'll do a really brief overview on how they work. User visits a malicious site, iframe is positioned over a link, user clicks link, click happens on iframe, okay? So the idea is the user doesn't really realize what they're clicking, and they're clicking and they're performing an action on an iframe that's potentially doing some sort of sensitive function, like maybe transferring money from a bank account or checking you out on some shopping cart application that you're logged into. So the way that this works is the header tells the browser if the page can be rendered in a frame. And there's a few options for X-frame options. There's deny, same origin, and allow from URI. It's still not a standard yet. I think the latest draft, although it might have been updated more recently, it was sometime in February. And also Google's been kind of pushing around a new header So Mike West has put that he thinks that they should add an allow all as an accepted value. And originally when I read what the purpose of allow all, I kind of was a little confused on why that would be a good idea. Because basically what allow all does is it allows a resource to be framed by all origins. So it basically turns off the protection. But then my thought was that, I haven't asked him, but my thought was maybe that the purpose of specifying the allow all origin is to kind of fundamentally shift the use of X-Frames options as more as a default header and potentially use that so that every site is sending that allow all header in the event that they don't already have the option configured, and kind of change a little bit of the security model and force people to start using this technology. I think that's the purpose, but we'll have to kind of see how that pans out. So from a security perspective, if we see this option enabled, we really should check the allow from scope. Check the URI that's allowed and is there vulnerabilities associated with that? And as has been discussed, I think Zelinsky or one of the other AppSec gurus did a really cool demo of how to kind of get past all clickjacking stuff by doing sudden redirects. And basically that's the concept of, we have a user clicking on a page or clicking on a page. While they're clicking, a request is made that pre-caches the resource that you would potentially have used in an iframe for a clickjacking attack. It does a quick 302 redirect. You accidentally click that portion of the page where the redirect happens, and you transfer money into your bank account or something like that. It doesn't really address that sort of attack, but it does address the more common kind of clickjacking attacks that we've seen. So, from an implementation standpoint, really what developers should do is just deny this when possible. Be as limited with your scope as you possibly can if you don't want your content embedded in iframes. So that's kind of my recommendation on that. We have enough time to do this one. You want to go through it? Cool.
So something that isn't a header, JavaScript cryptography. There's been a lot of talk in the last year or so in the security community about how bad JavaScript cryptography is. Montesano, a Chicago security firm, wrote a really awesome white paper talking about how stupid it is and how you should never do JavaScript cryptography. Their main contentions with it were that there's not good native JavaScript API support for it, so you can't get good pseudo-randomness. Their other problem with JavaScript cryptography is that if you can't trust the server that you're sending data to do cryptography on the server side, then why can you trust that server to send you valid JavaScript that is going to do the cryptography correctly? And I think those were all good points. My only contention with that, and the only reason why I think that JavaScript cryptography could be useful, is if you're going to be taking that JavaScript and trusting that one server, and then doing cryptography on data and sending it to another server. So if the server hosting the data and the server hosting the code are two different servers, and you don't trust the server hosting the data. So luckily, we don't need to do all the cryptography primitives in JavaScript anymore, because soon we will have this window.crypto API, which is going to provide us with a lot of the cryptography primitives directly in JavaScript. So we can get things like good randomness, and we can get a lot of these other algorithms and primitives implemented in faster code for us. Because another problem with JavaScript cryptography has been that it's really slow. So some of the API methods that you'll be getting: window.crypto.encrypt and decrypt. With these, you can specify what algorithms you want to use. It's a little bit up in the air in terms of what algorithms the browser is going to actually implement, but expect some pretty standard things. Another issue that's been talked about a fair amount recently with this API is that it's going to be supporting a lot of legacy algorithms. And the concern with that is that people are going to start doing cryptography bad, like they always do, and using these really crappy cryptography algorithms because the browsers are supporting them. They see that it's in this shiny new JavaScript API, so they think that it's safe to use. But definitely do your research before you decide on an algorithm if you're going to be doing some JavaScript crypto using the new API. Other methods that you're going to get: sign and verify. Going to be doing HMAX. You're going to have a little bit of ability to do public key cryptography. So you can generate keys, drive keys, import keys, export keys. Importing and exporting, it's a little bit I think there's still some work to be done here. Right now, some of the implementations I've seen, people are storing this stuff in the local store, but I was just talking with some folks earlier. It'd be pretty cool if this was stored out of band, out of scope, so that the JavaScript couldn't actually access the key material. Just something to think about. Some of the algorithms that are going to be supported, so the signing and verifying, the recommended one that the specification recommends that all browsers implement, SHA-256. You guys can read this. I don't feel like reading a bunch of letters and numbers. So yeah, more cryptography, more security. As I said before, there's a really good paper that you guys should read from Montesano about why you shouldn't do JavaScript or cryptography in JavaScript in the first place. A lot of those points are still valid. Just because we get this new API doesn't mean that it's a good idea. If you don't trust the server, you probably shouldn't trust the JavaScript that it's sending you. Shortcomings, like I mentioned before, support for old algorithms that shouldn't be used in the first place. It could encourage developers to use insecure algorithms. Another issue that I noticed when I was reading through the spec, the specification does not go into great detail about how entropy should be collected. The API is going to provide you with some pseudo-randomness, but there's not a whole lot of details on how it should gather that randomness. So it's going to be interesting to see as the browsers start implementing this, where they're getting the entropy and the quality of the entropy that you get in this JavaScript API. For people who want to start playing with this now before the browsers start supporting it, polycrypt.net, it's a JavaScript polyfill that does all of the cryptography primitives directly in JavaScript, and it mimics the API directly. So if you go ahead and build your JavaScript crypto application using the polycrypt library, then when the browsers start to support the crypto API, then you can switch over without having to change your implementation because the API is identical.
Cool. And then just a couple of comments on stuff to keep in the back of your mind for like the next year or so. We just kind of listed some things that I think will be interesting on an AppSec perspective, things like universal cross-site scripting, so the idea of finding a cross-site scripting vulnerability in a browser instead of in a web application, which is kind of interesting. So you'd be able to trigger cross-site scripting with a browser vulnerability. I have a node engineer on the Google Chrome team who recently found a universal cross-site scripting vulnerability in their browser and was able to use it to bypass content security policy and the stuff that we were talking about. Third-party plugins, APIs, mobile applications. There's still definitely some misconception of how easy it is to proxy and work with mobile applications and their back-end services. The same goes with APIs. Just because you don't have a WSDL or a well-formatted document doesn't mean a persistent attacker can't eventually figure out how to make requests for those services. And then things like framework vulns. I mean, there's been quite a bit of Rails issues lately, so keeping an eye on popular web frameworks and the kind of vulnerabilities associated with them could potentially allow you to perform some attacks and bypass some of the protections we were talking about. Once again, Ben's application that you can play with the browser statistics is up on his personal domain here, so definitely copy down that address and take a look at those graphs, and then we have a whole bunch of references. And that pretty much concludes our talk. Thank you, guys. Do you have any questions?
Cool.
Cool. Thank you.